The model of universal acceleration states the Earth is accelerating upwards. We are pinned to the surface of the Earth as a mechanical function of this acceleration. This is what creates gravity as experienced on Earth. There are numerous pieces of evidence that the Earth is accelerating upwards. One of the primary proofs for universal acceleration is the fact that bodies fall without inertial resistance. It is an unexplained coincidence that inertial mass is exactly equal to gravitational mass. This coincidence has been called one of the deepest, unsolved mysteries that exists in fundamental physics, and is a question which has vexed science for hundreds of years. Not only is it a conundrum that the inertial mass laws should equal out for gravitational mass, but the strong form of the equivalence principle declares that all laws of physics are the same. Why does the physics of gravity behave exactly as if the Earth were accelerating upwards? The universal acceleration answers this long-standing mystery, which has baffled generations of scientists by positing that the Earth is accelerating upwards. Despite great effort, the mechanism for gravity has not been discovered. Inertial mass is exactly equal to gravitational mass. There are two ways of thinking about mass. According to inertial mass, an object's mass is its resistance to being moved, this being greater the more massive it is. The other way to think of mass comes from gravity. According to gravitational mass, the force of gravity experienced between two masses, such as an apple and the Earth, is proportional to the product of their masses divided by the square of the distance between them. This force causes a falling apple to accelerate. If the two definitions of mass are exactly the same, the gravitational acceleration doesn't depend on the amount of mass being accelerated. Think about it. If, through the laws of inertia, a heavier mass has greater resistance to being moved, why should gravity accelerate both a bowling ball and a marble at the same rate towards the Earth without exhibiting any difference in inertial resistance? Any body that is being pulled or pushed through space should be subject to the laws of inertia. Bodies of a greater mass experience more inertial resistance than bodies of a lesser mass. It takes more force to move a greater mass through space. So why should both a bowling ball and a marble be pulled through space at the same rate? Imagine that you are stationary and standing on the surface of the Earth. Gravity feels like a force that is holding your gravitational mass to the Earth's surface. Yet when you are standing in a rocket undergoing accelerated motion, far from gravitational fields moving with an acceleration of 1g, the principle of equivalence tells us that there is an identical force exerted against the rocket floor by your inertial mass. However, this force is now caused by your dynamic accelerated motion through empty space. While standing on the Earth, however, you are definitely not in motion. Why should there be such a deep connection between what appears to be two completely different physical phenomena, a static force of gravity with no apparent motion, and a dynamic force due to the accelerated motion of your mass? In other words, why should you weigh the same in the rocket as you do on the Earth? The principle of equivalence encompasses this strange coincidence, and is one of the founding postulates of general relativity theory. In its stronger form, it states that all the laws of physics are the same in the above thought experiment. When stated in its weaker form, it implies that objects of different mass fall at the same rate of acceleration in a uniform gravity field, and that only laws of motion of physics are the same. Equivalence also means that the inertial mass, that is the mass defined by Newton's law of motion, mi equals Fi divided by g, is exactly equal to the gravitational mass, which is mass defined by a completely different law, given by Newton's universal gravitational law, mg equals Fgr squared divided by gm, where mi and mg are the inertial and gravitational mass of an object, Fi and Fg are the inertial and gravitational forces exerted on the object, g is the acceleration of the object, m is the mass of the Earth, r is the distance from Earth's center, and g is Newton's universal gravitational constant. Newton was well aware of this coincidence of mass equivalence, which we refer to here as the Newtonian mass equivalence principle. The equivalence principle demands that mi equals mg. Why should this be true in our universe? It has been about 85 years since the discovery of the Einstein equivalence principle, and hundreds of years since the discovery of Newton's mass equivalence principle. Yet, it is still not understood why inertial mass exists in the first place, or why a mass opposes acceleration with a back-acting inertial force. More importantly, It is also not known why there are two totally different physical definitions for inertial and gravitational mass, instead of just one. Furthermore, masses can have different temperatures and therefore different energy content, and may be composed of different materials like lead, wood, water. Again, why should MMI equal mg, no matter what the material composition and the energy content that a mass may contain? In short, the principle of equivalence is one of the deepest unsolved mysteries that exists in fundamental physics today.